We're going to look at a special type of column graph called a histogram, and we're going to do it with discrete and continuous data, and we're going to look at ungrouped and grouped data as well. So quite a bit to learn about in this video. Let's go straight into an example. 20 people were surveyed to find out how many times they use social media in a week. The raw data are listed, so we've got our data there. So firstly, let's think about what sort of data that is. That is not continuous, is it? Because it only takes set values and it's discrete. So we've got discrete data, and we don't have a choice whether we're going to group it or not, because it tells us we've got to use these things called class intervals, and that's basically the size of the grouping. So each class interval should be the same. So that's always the same. Okay, so it's not always 10, but if it's 5, it has to be 5 for all classes, for all groups. This one, we're supposed to use 10. You can see the table there. So class interval is a proper name for the group. You can see that straight away. We've got small values, so we're going to start at 0. And we've got nothing above 50, so we're safe to stop the table at 50. You'll see this written in a bunch of different ways, the groupings. Just make sure you don't put, you can see the first one goes 0 to dash. Well, that means it's got to be less than 10, because don't say 0 to 10 and then 10 to 20. That would not be good, because if something was 10 exactly, there'd be confusion about which class, or if something was 20 exactly, which class interval would it go in. So don't do that. But you can do it, what's written here. That just means from 0 up to everything less than 10, not including 10. But because this is discrete data, that would be 9. It couldn't be anything between 9 and 10. So you could write those in for discrete data. With continuous data, which you'll see later in the video, it's a little bit different. So perhaps that should say 49. That's a little bit dodgy what's there. So 49. So because the class width would be 11 otherwise. You see, that is a class interval of 10, because it's including 0 as well. So basically 10 different values, because it is discrete. Of course, the way it was originally is fine, except for the 50. That's not fine. Probably shouldn't be 50. So we've got frequency there, and some of them have percentage frequency. Now we work out the percentage frequency if it's asked for by looking at the total. So there were 20 scores, and 2 out of 20 is 10%. 8 out of 40 is 40%, and so on. And of course, that should add to 100%. So percentage frequency literally is what percentage of the total is this frequency. And remember, the word frequency from your earlier studies is how often something occurs. So the important part now is drawing a histogram. So because I want to save time in this video, you'd write your proper title there. So title. And you should label your axes with units and a title, a subtitle for the axis. Same here. Label. Just to save time, I'm not going to do that. And basically, we've got to look at how many columns there's going to be. 1, 2, 3, 4, 5 columns. And we could probably fit that in there. 1, 2, 3, 4, 5. Yep, good. Now, the columns do not have any gaps between them, and they're all the same width on a frequency histogram. There is if we can make see how there's 2 grid lines. They're going to be the difference between the edges of every column. So every column will be 2 of these units wide. Now, notice how I've deliberately left something here. That has been left empty, and that's a half column width. Okay, so a half column width there. If one column is 2, Units, this half column is 1 unit, so you need to leave that there. Sometimes books and people forget to do that, but you should leave half of the column's width there empty. So make sure you do that. Alright. Now to save time, I've just put on a whole lot of other stuff there. So you can see I've got a title, I've got labels on the axes, and I've got increments. So you can see we're going to plot basically two histograms on the one graph. So in green will just be the regular histogram, and in blue will be a percentage frequency histogram, which is from that last column. So firstly, the regular frequency histogram, so we can see we've got 2, and it's simply just like a column graph. It's going to go up to 2 there, and whether you use software or you're ruling it up with pen and paper, we've got the first one there. Okay, and the second one is 8, so it'll go way up here, annoyingly through the middle of my title. Bye-bye title. So hopefully you paused the video before and you got your own copy of that. You'll have to review the video or rewind it if you didn't get it, because that's 8 up there, or 80%. So okay, the 20s, so 20 number of time in the 20s per week for users. So we've got 5, so we can see that goes there. You should rule this if you're using by hand like me with my stylus. You've got 4. I think you get the idea. 1. Notice there's no gaps, okay, and it should be perfectly straight ruled lines. If we color it in, they should all be the same. It should all be the same color. And I'm not going to color this one in because there's 2 histograms there. I don't want to confuse things. But yeah, normally we would shade all that in with a color, like so. The reason will become more apparent in future years when you look at things like probability density functions, where we use the area. Now for the percentage frequency, so we've got 10%, then we've got 40%. Notice how I'm using the blue scale now. It's not always a good idea putting the 2 things on the one graph. For 25%, so we've got there. We've got 20%. Notice there should be no gaps between the columns, and we have 5%. So we have 2 histograms on 1. So this was for grouped data with class intervals. It was discrete data. If we have continuous data, now this is continuous because we're talking mass. We've got some data given, and we've got, this is mass of people, 40 people, hence the total there. This one doesn't have the percentage frequency. We're not going to do that for this one. Notice this here, the class intervals are given of 10. Now, to avoid a double up, 70 there and 70 there, we say from 60 up to less than 70. So that would be on a number line. It would be from 60. So I will color in red. So 60 up to, along the number line, up to everything. Now 70's up here. It does not include 70, so it stops there and excludes 70. That way the next class interval can include the 70. So we can see that they've got the half column width gap there, which is good. We've got labels, we've got no gaps, same width columns, shaded all the same color, title. It's a very nice histogram there. The units are there, and so that's how you do it, and that is for continuous data. and it's continuous, and it's grouped into class intervals. Why is some data grouped and not grouped? Well, if there's a lot of data and there's repeating values that are just a little bit far apart, especially if it is a lot of data, it makes sense to group it. If we just lose the individual data, that's all. That's the only disadvantage of it. So sometimes you have no choice, but other times you have to decide whether to group it or not. If it's a lot of data, yeah, usually group it. So we haven't seen an example where it's not grouped, and we've got a number of children in a family. So this is discrete and ungrouped. So discrete, because it's the number of children, and ungrouped, because there's only 20 people, so you can get away with ungrouped. So basically, note how the main difference here is on this axis, we've got the columns I'm putting them there in an alternate color so you can see. Notice how if it's not grouped data, so these are all the families that had 0 children. There were 4 of them. But because it's not an interval, it's just a score, the label goes in the middle. Okay, the increment goes right in the middle. It straddles it, and in the column it sits either side. It's still symmetrical. That's still a good histogram. It's got the half column width and all those other features there. So, in summary, let's have a look. Okay, hot tips for histograms. So, yes, it's a special type of column graph. It must be drawn with the following characteristics. All columns are of equal width. No gaps are left between the columns. For ungrouped data, each column straddles an axis score, just like we saw in the last example. The column starts and finishes halfway between the scores. And for group data, which was the first 2 examples, means they're in class intervals, the class limits sit on the edges or the extremes of the columns. And usually a half interval or a half column width is left at the beginning and at the end. Now, we didn't see it at the end, but one day when you draw polygons, you'll need to put that half interval at the end. That'll come in the future.